Hello, this is day 4 of the daily push-up challenge while solving some Putnam problems. Let's go. Incline push-up. 1, 2, 3, 4, 5. Okay, our Putnam problem today is from 1990, and typically, usually one of the Putnam questions they always include the year within their problem. So this like one of those examples in here. You see the 1990 from here, but the question reads: find all real valued continuously differentiable functions f on the real line such that for all x, f of x squared is equal to the integral from 0 to x of f of t squared plus f prime t squared dt plus 90. Okay, so let me think how to attack that. 6, 7, 8, 9, 10. Okay, so to get rid of the nasty integral, what we can do is we can like take the derivative of both sides. So you get on the left hand side 2 f of x multiplied by f prime of x, of course, by chain rule. And then on the right hand side, since that's just an integral and then x is one of the limits, then the derivative is just the integrand, evaluated at x. So this is f of x squared plus f of x prime squared, and then of course 90 is a constant, its derivative is equal to 0. Of course, this can be written as f of x squared minus 2 f of x f prime x plus f prime x squared is equal to 0, correct? 11, 12, 13, 14, 15. Okay, and of course, from here, we can easily see that this is factorable, right? You can write this as f of x minus f prime of x squared equals 0. Okay, so this of course implies that f prime of x, the derivative of the function we're looking for, is equal to the function. Okay, and of course this is an elementary differential equation. This implies that the function, the derivative of a function is equal to the function itself. That is just equal to some constant e to the x. Okay, but the question is, are we done? Okay, the thing is, not all of this c e to the x for any value of c, not all of these can solve the function. Okay, in other words, we need another condition in order to determine uniquely what our c is. 16, 17, 18, 19, 20. So what is that condition? So note that our initial attack is to set the derivative equal. So for example, if you call the function on the left hand side, I don't know, gx, and then the function on the right hand side as h of x. Okay, so this entire thing on the right is h of x, this entire thing on the left is g of x. What we did is we let g prime of x is equal to h prime of x. But the question is, when two functions have equal derivatives, are they necessarily equal? That's an awesome question, So can we say for certain that once you know that the functions have equal derivatives, does it imply that the function is equal themselves? And the answer is no. Of course, you can easily see that because the equality of two derivatives implies that g prime minus h prime is equal to 0, which implies that, of course, since derivative is linear, g minus h prime is equal to 0. Okay, so this implies that if g minus h prime is equal to 0, that means g minus h is equal to some constant, let's call it k. Okay, so in other words, if the derivatives of two functions are equal, then it doesn't necessarily mean that they are equal. But we know that if the derivatives are equal, they only differ by a constant. Okay, so this is the second condition that we want. So two functions differ by a constant. So what we want is for those two functions to be equal. Okay, so what do we do? For two functions to be equal, we show that they are equal if any of their points within the real line, okay, since they only differ by a constant, one function just shifted away from the other. If we can find a single point along the real line where they coincide, they must coincide everywhere else. In other words, if there's a point where they are equal, they must be equal everywhere else if their derivative is equal in the first place. That point we can take to be 0, okay? Why? Because if we set x equals 0 in our original problem right here, in the original equality, f of 0 squared, that equals to the integral from 0 to 0 of whatever it is, whatever the integral is, since the limits are now equivalent, this will become 0, and then we are left with 90. In other words, f of 0 is equal to plus minus the square root of 90. So this is the second condition we need in order to determine correctly what is C right here. Because now we know that f of 0 from this equation is equal to C, but we know that that is just equal to plus and minus square root of 90. Okay, so in other words, the function that we need with the unique coefficient with a unique constant determined is now equal to plus and minus square root of 90 e to the x. Okay, so this function, even if you try it, should solve the equality above. Okay, 21, 22, 23, 24, 25. All right, so that should conclude it. So I've seen Alberto doing the diamond thing, you know, like your hands are close together, but I can't possibly do that with my iPad in front of me, right? So we just remain the ones with the hand apart. But anyway, this is day 4. Thanks for watching, guys. I'll see you next time. Bye-bye.